So question number 4, those who have not done it, so I'm doing it for them. Express 0.999 in the form of p by q. Same process just like the earlier ones, the earlier non-terminating decimals that we have expressed it in the form of rational numbers. So same thing we have to do it here. So what we'll do, first thing, let x equal to 0.999. Okay, so this one you mark as 1. Next thing, you see what digit is repeating, right? Only 9 is repeating, that means one digit is repeating, right? So equation 1 into 10. So here 10 into x, and this side also 10 into 0.9999. 10 into x is 10x. If you multiply 10, the decimal will move one step towards the right. So if the decimal is here, it will come here, right? 9.999. Sorry, here I forgot to give dot. So you give the dots here. So 9.999 dot. After that, this is equation 2. Now what we will do, equation 2 minus equation 1. So equation 2 minus equation 1. So 10x minus x equal to 9.999 dot 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 minus 0.999 dot dot dot. 10x minus 1x is what? 9x. Here you see after the decimal all are 9. That means 9 gone. So 9 minus 0. Before the decimal, what is there? 9 and 0. 9 minus 0 is 9. So if I send the 9 that side, it will be 9 divided by 9. 9 ones are 9. So what is the value of x? 1. Instead of x, I can write what? 0.999 dot 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 is equal to what? What is the answer? 1. I hope it is clear. Let us move to the next sum. So question number 5. What is the maximum number of digits in the repeating block of digits in the decimal expansion of 1 by 17? So there is a fraction given, or there is a rational number 1 by 17, and when we divide it, then in the decimal, obviously the decimal will be what? It will be non-terminating and recurring, but in the recurring group of digits, how many digits will repeat? Maximum how many digits will repeat? They are asking that. So in order to find out that, we have to divide it, right? So our first task will be to divide it, right? So if I actually go to divide it, it will be too much longer. But like this question, it hardly comes in exam. But even if it is asked to do it, then you have to divide it. But since if I do keep on dividing, then it will take a lot of time. So I am just giving you the idea how to do it, and you can divide and find out the answer. Okay. So 1 by 17, you divide 1 by 17. 17 zeros are 0. 1 decimal 0 came. So 17 zeros are 0 again, because 10 is smaller. So 10 0 k. 17 5 ja 85. Then 15. After that 0 will come. 17 8 ja 136. After that 14. Like that it will go on. Okay. Now why I am telling you it will take a lot of time, because here you know how many digits will be there, after which it will start repeating again. Here 16 digits will be there. How many digits? 16 digits. That's why it will take a lot of time. After that it will again start repeating from 058 like that. Okay. Again after 16 digits, again it will start repeating. So how many digits? When you will divide it, it will take some time, but when you will divide it, you will come to know that 16 digits will be there. Okay. So I'm just giving you the idea how to do it. You divide and you will get the answer. It will just take some time. Okay, so therefore maximum number of digits in the repeating block is, how many digits are there? 16 digits are there. Okay, I hope this clear. Let us move to the next question. Question number 6, you see, look at several example of rational numbers in the form of p by q. So some parts were extra. I have just, means in the question I have just made it shorter here. Having terminal decimal representation, so you have to check rational numbers that have terminal decimal representation, and you have to guess what property q must satisfy. Okay, so let us try to see the rational numbers first and see what kind of decimal expression they have. Okay, first let me take one example. Let me take the example of 7 by 5. If I divide 7 by 5, okay, 5 ones are 5, 1.4 I got remainder 0. So this is a what? Terminating, right? Terminating decimal. Next, let me take one example of 1 by 2. What I will get? 0.5. This is also terminating. Let me take one example of 3 by 8. Okay, 8 zeros are 0, point given, 8 threes are 24, 6 0, 8 sevens are 56, 8 fives are 40. So 0.375. Okay, but if I say, I'm just giving you some example, this is also terminating. Okay, now if I take 1 by 7, 0, 7 1 are 7, 7 4 are 28, 7 2 are 14, 7 8 are 56. So you see it is going on. So this is non-terminating, right? Now what you have seen common here, you tell me, this all are terminating, na? Between these terminating rational numbers, what you have seen common? They are asking the property of q, right? So let me tell you something very important. For a rational number to have terminating decimal, the q, you see q is either 5 or 2 or power, it is power of 2 only, na? Power of 2 or both combination of power of 2 and 5. That means, suppose when I have 25, 25 is 5 square, that means it will again have terminating decimal. If I say 16, 16 can be written as power of 2, 2 to the power 4, again it will have terminating decimal. But if I can also use like that, 40, 40, 8 5 is 40, 2 cube into 5. Combination of power of 2 and 5. That means this one will also have terminating decimal. But apart from that, if I use any other thing like 7 by 9, so this one will be non-terminating, because here there is no power of 2 or 5 or no combination of them. So this one, other than that, it should be, the q must be in power of 2 or power of 5 or combination of both power of 5 and 2. Apart from that, others will all have non-terminating decimal. I hope it is clear. So I'll just write a property here. Q must be a power of 2 or 5 or combination of both. I hope it is clear. Let us move to the next question. So next question number 7. Write three numbers whose decimal expansion are non-terminating and non-recurring. You have to give three example of numbers whose decimal expansion are non-terminating, that means it has no ending, and non-recurring, that means there is no repetition. Like that is only possible in case of what? Rational or irrational numbers, irrational numbers, right? So we have to give some example of nothing but irrational numbers, right? So let us take the first example, root 2. What is the value of the decimal expansion? 1.414. It will go on, so you just write dot dot dot. Then if I see root 3, 1.732. After that it will go on 0 and then dot 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 you give. Next pi 3.141 dot dot dot. So therefore three numbers are root 2, root 3 and pi. Question number 8. Write three different irrational numbers between 5 by 7 and 9 by 11. Okay, so 5 by 7 and 9 by 11 is in fractional form. So now let us write the decimal expansion of it, then only we can write the numbers now. So 5 by 7, if I divide, okay, if I divide 5 by 7, 7 zeros are 0, since 5 is smaller, 7 7s are 49, then 1, again 0 came, 7 1s are 7, 3 30, 7 4s are 28, 20, 7 2s are 14, 60, 7 8s are 56, 40, 7 5s are 35, 7 7s are 49. So you see, again it is repeating from here. Now it is again repeating from 7. So you can write 0.7142285 bar. Again you have to divide 9 by 11. So let us divide. 11 zeros are 0, since 9 is smaller, 0.90, 11 8s are 88, 2, 11 1s are 11, again 9 came, 0, 11 8s are 88, 20, 11 1s are 11. So it is going on like that. So you see 81 is repeating, so on above 81 you put a bar. Now you have to write the rational numbers between them. That means you have to write basically three different irrational numbers between them. Now 0.714 it is there, so I can write what? 0.72435. Don't worry, it has no pattern. Okay, just between 81 and 71 you write some numbers, dot dot dot. Okay, so here you write three irrational numbers. This is the first one. After that 0.75678 dot dot dot. After that 0.79235 dot dot dot. So it will go on like that. Okay, I hope it is clear. You just divide, and after getting the decimal expansion you just write the numbers between them. That's it. Okay, let us move to the last question, number 9. So now last question, number 9. Classify the following as rational or irrational numbers. So we are given some numbers and we have to tell whether they are rational or irrational. Okay, so let us look at the first question. Root over 23. Now you tell me, is 23 a perfect square? No, it is not a perfect square. So that means 23 will just remain in a square root. And like these numbers are always rational or irrational, they are irrational. So root over 23 is irrational. Root over 2, root over 3, root over 23, These are all irrational. Okay. Next, root over 225. Now you tell me, is 225 a perfect square? Yes. 225 is whose square? 15 square, right? So square root cancel, and what is left? 15. Now is 15 a rational number? Yes. So 15 is a rational number. Next, 0.3796. Now this decimal is not going on, it has stopped here, right? So it has an ending, so this is a terminating decimal. Terminating decimal are always rational, so it is a rational number. Next, you see it is non-terminating since it is going on, but it is recurring, the digits are repeating. That means you can write here 478 bar dot dot dot. So 478 is repeating now. Okay, so it is non-terminating and recurring. Now what I told, non-terminating and recurring, that means if the digits are repeating, then we can convert it into rational number. So this is a rational number. So how we can convert it? Question number 3 we have done or not? Question number 3, the decimals were non-terminating and they were recurring. Repetition was there, but we have converted it into rational number form, P by Q form. So like that we can convert it. Same thing here also. This one also we can convert it or not? We can surely convert it. So it is a rational number. I hope it is clear. Now next, last number 5, you see 101, and this is 001, then 001, then 4 zeros and 1. You tell me, are the digits repeating here? No, digits are not repeating. You see 1, then 01, then 001, then 0001, then 401. They are all are different digits. It might look, but if you observe carefully, here the digits are not repeating. So this is non-terminating and non-recurring. That means surely it is a irrational number. I hope it is clear. Thank you.